Welcome to The Explainer. Okay, today we are looking at an absolute earthquake in the AI landscape. On August 5th, 2025, OpenAI dropped something we, the developer community, have literally been waiting years for, a massive open-weight release. We're talking about the brand new GPT-oss series, specifically the 120b and 20b open-weight reasoning models. And look, this isn't just some research preview, right? These are highly capable, tool-using reasoning engines that you can download and run right this second.
So let's dive right in. Here's our roadmap for the explainer today. First, the return to open weights. Then, under the hood, followed by the Apache 2.0 Advantage. Next, Harmony and agentic tools. And finally, from PC to data center.
All right, Section 1, the return to open weights. OpenAI shifts the AI landscape.
To really grasp the impact of this release, we've got to look at the historical context. For years, the frontier of AI has been heavily guarded behind API paywalls and cloud endpoints. But as this quote pulled straight from Dudarik.com highlights, this is OpenAI's first open-weight models since GPT-2. I mean, just think about how long ago GPT-2 was in AI years. It's basically ancient history. Sure, we've had a few specialized small releases here and there, but dropping fully functional frontier-grade reasoning models out in the open, that is a massive return to their roots. And honestly, the shockwaves are still being felt by developers everywhere.
Okay, moving to Section 2, Under the Hood, Deconstructing GPT-OS.
So let's get a bit technical and actually deconstruct what you're getting when you pull down the repository. OpenAI basically released two distinct flavors here, optimized for very different environments. And this brilliantly illustrates the contrast. On one side, we've got the heavyweight champion, the GPT-OS-120b. This guy is built for production and intense, high-level reasoning tasks. It packs 117 billion total parameters. But, and this is key, because it's so highly optimized, it actually only uses 5.1 billion active parameters per token. That means it can squeeze onto a single 80 gigabyte data center GPU, like an NVIDIA H100. Then, on the other side, we have the lightweight contender, the GPT-OS-20b. Built for lower latency and local use. It has 21 billion total parameters with just 3.6 billion active. And the best part? It's designed to run beautifully within just 16 gigabytes of memory.
Now, digging a little deeper into these engineering stats provided by NVIDIA, you can really see the magic of the mixture of experts, or MO, architecture at play here. Look at the total versus active experts. The 120b model has an incredible 128 experts, right? But it only routes to 4 active experts per token. That is exactly how it achieves such high reasoning without completely melting your hardware. Also, notice the context length on the far right. Both models feature a massive 128K sliding window context. To put that into perspective, they can ingest entire books or massive codebases in a single prompt. Pretty wild.
But you might be wondering, how on earth do you fit 117 billion parameters onto a single 80 gigabyte card? Well, the answer is MXFP4 quantization. This is a native post-training weight precision format that uses 4-bit floats. Essentially, it allows these massive MOE models to drastically reduce their VRAM footprint right out of the box. You don't have to compress it yourself and accidentally ruin the performance. All the official evaluations were actually run on this exact MXFP4 quantization, meaning the high scores you see reported are the exact scores you're going to get on your own hardware.
Section 3, the Apache 2.0 Advantage, Unlocking Commercial Deployment.
Now, having great tech is one thing, but actually being legally allowed to use it? That's a whole different ballgame. So the crucial point here is that OpenAI released this under the incredibly permissive Apache 2.0 license. Unlike some other open-weight models out there that slap you with strict commercial limits or copyleft restrictions, Apache 2.0 means you can deploy this commercially, today. You can fully fine-tune the parameters for your specific startup or enterprise use case without worrying about paying per-seat fees. It's a real game changer. However, there is a catch. You must adhere to OpenAI's supplementary usage_policy file, which is included in the repo. That adds some behavioral constraints, so definitely always read that file before you push anything to production.
Moving right along to Section 4, Harmony and agentic tools. How to actually run the models.
Okay, so now that we know we can legally run it, how do we actually make it work? These aren't just your standard autocomplete engines, They are literally designed to act as autonomous agents, which means they require a very specific software setup. A super critical piece of this puzzle is the Harmony format. This is OpenAI's strictly required response format for all conversation structures, reasoning outputs, and function calls. The documentation on this is crystal clear. The GPT-OS models will not work correctly without it. If you try to skip the Harmony format and just call model.generate directly in your code, the model probably won't crash, but its output will silently degrade. So pro tip, always use their provided chat templates or the OpenAI Harmony package to make sure your prompts are formatted the right way.
Let's see how this builds, because once you have Harmony set up, you unlock this awesome feature, configurable reasoning effort. You can actually explicitly instruct the model right in the system prompt to use one of 3 levels. Low gives you fast, low latency responses for just general chat. Medium is your middle ground. It balances speed and detail. But high? That unlocks deep, detailed chain-of-thought analysis. Basically, you are in total control. You can trade latency for intelligence on a prompt-by-prompt basis.
And what can it actually do with all that reasoning power? Well, a lot. These models come packed with native, out-of-the-box agent capabilities. They were explicitly trained from the ground up to use tools. They can natively browse the web. We're talking searching, opening, and finding text on live pages. They can write and execute Python code in an isolated container to solve complex math or data problems. They even support advanced function calling with strictly defined schemas and guarantees structured outputs. They are, for all intents and purposes, ready-made agents right out of the box.
And to make building those agents even easier, OpenAI included something absolutely huge in the repository, an MCP server, or Model Context Protocol server. This is the exact same protocol used by major players like Anthropic for tool use. By including a GPT-oss-MCP server directory, developers can seamlessly integrate this model as a drop-in replacement into their existing local agentic workflows. We're talking zero network latency, zero API costs, and total uncompromised control over your tools.
All right, let's head into our final section, Section 5, from PC to data center, deploying GPT-OS today.
So, we've covered the specs, the license, the tools, but where do we actually run these things in the real world today? Well, let's start with the desktop. And honestly, this is exactly why this release matters so much. True OpenAI-grade reasoning is no longer locked behind a cloud API. Because of that MXFP4 quantization we talked about earlier, the 20B model can be deployed completely locally on literally any NVIDIA GeForce RTX AI PC that has at least 16 gigabytes of VRAM. You can just pull it down using Llama or LM Studio, and boom, you have a world-class reasoning agent running entirely offline on your own local machine.
Now, what's really interesting about this slide is looking at the other end of the spectrum, the sheer scale of deployment. 1.5 million. That is the staggering number of tokens per second throughput that NVIDIA engineers achieved running the massive GPT-oss-120b model on a single NVIDIA GB200 NVL72 rack-scale system. To put that into perspective, that translates to serving something like 50,000 concurrent users with blistering speed. It just proves that these models aren't just little toys for tinkering. They are heavily engineered for massive enterprise-level deployment.
What's also incredible is the ecosystem support on day 0. It's been practically unprecedented. You don't have to reinvent the wheel here. You can run these models using Hugging Face transformers. You can serve them up for high throughput with VLLM using the UVFF package manager. You can optimize them with NVIDIA TensorRT LLM or NIM microservices. You can deploy them on managed cloud providers like Amazon Bedrock and SageMaker AI, or, as we mentioned, just run them locally via Llama and Llama.cpp. Basically, the entire AI software stack is ready and waiting for GPT-OS.
Which brings us to our final thought for today's explainer. The barriers are gone. The weights are completely open. The reasoning can be tuned to your exact needs. The tools are built right in, and the hardware requirements are incredibly flexible. So, with OpenAI-grade AI now sitting squarely in your hands, the only real question left is, what will you build first? Get out there, check out the repository, and start coding. Thanks so much for joining me on this explainer, and I'll catch you on the next one.